Hello dear learners. In this video, we will study about determinants. We will learn what are determinants, how they are being evaluated and what are their applications. So objectives for this video session are, at the end of this video, you will be understanding what is a determinant. You will be able to illustrate the similarities and dissimilarities between matrices and determinants. You will be able to evaluate determinants of order up to 3. You will be able to apply determinants to evaluate area of triangle as well as equation of straight line. So let's learn how to evaluate or expand determinants. So let's learn how to write equations in the form of matrices. In class 10th, you have studied about linear equations which are represented as a1x plus b1y is equal to c1, where a1, b1 and c1 are constants and x and y are variables. So this equation can be written again in the form of matrices as a1, b1 as a row matrix, x, y the variables can be written as column matrix, and this c1 can be written as matrix of order 1. So that when you multiply a1x plus b1y, you are getting this LHS of the equation is equal to c1, you are getting this equation back. Similarly, if we take system of two equations, equations are this and they can be represented by using matrices as a1, b1, a2, b2. This is matrix of coefficients into variables xy is equal to constants c1 and c2. So let's learn further. This system of linear equations will have a unique solution if a1 by a2 is not equal to b1 by b2. This you have done in class 10. So if I'll just cross multiply this b2 by this a1, what will I get? a1 b2 minus a2 b1. This must not be equal to 0. So this number a1 b2 minus a2 b1, this determines that solution of the equation is unique. Also this number is associated with this matrix. We can obtain this number from this matrix, which is matrix of coefficients of x and y. So this number is called determinant of the matrix A. Let us define what is a determinant. To every square matrix A of order n, we can associate a number which is real or complex. This number is called determinant of square matrix A, where this Aij is ijth element of matrix A. This is denoted by DETA, that is called determinant A. This can also be written as determinant A. This is not modulus A, this is determinant of A, or it may be represented by using this triangle. This is called delta. So if A is a matrix ABCD, then its determinant is represented by this sign and it is written as ABCD. You can check the sign of the determinant. So determinant of order 1. Let A be a matrix of order 1 by 1. So determinant A is this number A only. For example, if I will take matrix A as consisting of single element A1, then its determinant is 1. Let's learn how to evaluate determinant of order 2. Let A be this matrix. I have written all the elements in the generalized form. So how will you evaluate it? You will multiply this element with this element as the arrow depicts and this element by this. So A11 into A22 minus A12 into A21. For example, if we have this matrix A, so this element 1 will be multiplied by 4 like this, and this element 2 will be multiplied by 3. When you solve it, you are getting 4 minus 6 is equal to minus 2. Let's learn one more question from NCERT, how to evaluate this. So this determinant 2 minus 5, 4 minus 1 will be evaluated or expanded, you can say, 2 multiplied by minus 1 minus 4 multiplied by minus 5. When you simplify this, this becomes minus 2 plus 20. This is giving you plus 18. So, that becomes the answer, determinant A. You can also write this as determinant A. So, determinant A is giving you value 18. Now, let us learn how to evaluate determinant of order 3. Let this A be a third order matrix. So, how you will start? You write this element A11, write it here. Delete this first row and first column and write down the next determinant of second order. Write the next element A12. Delete first row and second column and write down the remaining 4 elements in the form of determinant. Then write A13. Delete this first row and third column and write down remaining elements like this. What you have to keep into mind is A11 positive, next element negative, then comes positive. This plus minus is going alternately. You have already learned how to simplify the second order determinant. So, we are using the same method here. Now, let us learn how to evaluate determinant of order 3. This is question number 5 from exercise 4.1 of NCERT. So, this is represented as determinant A. So, you take this first element 3, delete this first row and first column and write remaining elements, just solve them as second order determinant 1 by 1 minus minus 2 into 3. Then we will take the second element minus 4. I will write it here. This may be written in the same line. So, delete this column and this row where this element minus 4 has been placed and solve the remaining 4 elements as second order determinant. This becomes 1 into 1 minus minus 2 into 2. Then let us write the third one 5 and delete this row and this column where 5 has been placed and solve the rest of the 4 elements like this. 1 has been multiplied by 3 minus 1 has been multiplied by 2 like this. Then simplify this. So, this is 3, 1 minus of minus 6. So, that makes it plus 6 minus 4. This is 1 plus 4 plus 5. This is 3 minus 2. Then simplify this. 6 plus 1 7, 7 into 3 21, 4 plus 1 5, 5 into 4 20 plus 3 minus 2 1, 1 into 5 5. So, this is giving you 21 plus 5 26 minus 20. So, your final answer is coming as 6. So, this determinant is equal to 6. So, let us proceed further. Results on determinant. So, they are very important results. So, determinant exists only for square matrices as we have already seen. Determinant can be expanded along any row or column. We have just evaluated it by using first row. Determinant should be expanded by the row or column having maximum number of zeros. Why so? So that calculations become easier. While expanding, instead of multiplying by minus 1 raised to power I plus j, you can multiply by plus 1 or minus 1. Just keep them alternate. It depends on I plus j is even or odd. If A and B are square matrices of the same order, that means A is equal to KB. If we can express that, then determinant of A is equal to determinant of KB. That means K raised to power n. You can take K common from each row or column and then write determinant B. Let us do this question based on the last property, the last result. You are given this matrix A. You have to show that determinant 2A is equal to 4A. You can see this matrix is A, it is of second order, so 2 raised to power 2. That means by using that property I am getting this, which is equal to 4 times determinant A. Let us solve it. So let us first calculate value of 2A. That means each element will be multiplied by 2. You are getting this matrix. Then you can simplify this further by taking its determinant of 2A. This is 2 into 4 minus 4 into 8. This is 8 minus 32. So this is giving you 26. Fine. Sorry, this is giving you minus 24. Then let us take determinant A only. So this is coming as 1 into 2 minus 2 into 4, which is coming as 2 minus 8 or minus 6. When you multiply this by 4, you are getting 4 multiplied by minus 6, which is minus 24. So you can see that both the sides, both the numbers are coming as equal, or you can say that determinant of 2A is equal to 4 times determinant A. That proves our last result as well. Next question, what will be value of x if these two determinants are equal? You can recall in the case of matrices, what we were doing is we were just equating the corresponding elements, but that may not be the case in the determinants. So you have to simplify this by solving first determinant, that is equal to 36 minus 36. We have simplified this determinant also. So this is giving you x square minus 36 is equal to 0, which is giving us x square is equal to 36, which is equal to x is equal to plus minus 6. If you would have calculated these two determinants as equal, that means x is coming as 6, x is coming as 6, you would have lost one value, x is equal to minus 6. So next concept is area of triangle. How determinants are used in finding area of triangle. You can recall this formula from coordinate geometry in class 10th, that area of triangle with vertices these three, x1, y1, x2, y2 and x3, y3. This is the formula that you are very well aware of from the coordinate geometry. Can we write this formula by using determinants? Yes, we can. So area of triangle with vertices x1, y1, x2, y2 and x3, y3 can be written as half x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. This same formula is coming out from this determinant. Half is here, x1, y1, write it, x2, y2, write it, x3, y3. But if I am just closing it here, it is not becoming a square matrix. So I have to write 1, 1, 1. Why I have selected only 1? Because if we multiply any number by 1, the number does not get affected. So that is why to make it square determinant, we have written 1 in the last column. When you simplify this, you are getting this formula. So area of triangle, we have got this formula. So two remarks are there. Always take the absolute value of the determinant. Why? Because area is always a positive quantity. If area is given to you for the question or calculation sake, you can use both positive and negative values so that both the answers can be given. And last is area of the triangle is 0 if points are collinear. Obviously, if 3 points are collinear, then no triangle is made. In fact, the line becomes a single line. Now let us use determinants to find area of the triangle if we are given 3 vertices. So this can be solved by using the same formula. Area of triangle is half, write down the vertex, vertex 1, 1, 0, write 1, second vertex 6, 0, 1, third vertex 4, 3 and write 1. You can solve this by using column 2. Why? Because it is having 2 zeros and 1 constant. But if you are not comfortable, you can solve it by R1. So you can write 1, delete first row and first column and multiply remaining elements like this. Take next element minus 0, you do not have to write anything because if you multiply anything by 0, it is going to be 0. Take next element 1, delete first row and third column and write down remaining elements by multiplying them. 6 into 3, 18 minus 4 into 0, 0. Then you can solve it 1 by 2. This is minus 3, this is 0 and this is plus 18. When you simplify this, it is giving you 15 by 2 square units. Let's use the same concept in solving one more question in which you have to find the value of unknown k if area of the triangle is given as 4 square units and vertices of the triangle are also given. So you can equate this area of triangle, write down in the determinant form, write all 3 vertices like this. To make it square, write 1 in column 3 equated to 4 square units. You remembered, for calculation sake you have to take plus minus, which we will be taking in the next step. This becomes half. Solve this. This is k. Delete first row and first column for solving. It becomes 0 minus 2. Next element is 0. You do not have to solve anything. Take next element 1. Delete first row and third column and solve it. This is 8 minus 0. This is equal to plus minus 4. So solve it further. This is half minus 2k. This is plus 8 plus minus 4. Shift this 2 to this side. You will get minus 2k plus 8 is equal to plus minus 8. Here you will get two cases. So case 1, minus 2k plus 8 is equal to 8, and the second case is minus 2k plus 8 is equal to minus 8. Let us solve it. This 8 is cancelling on both the sides, so it becomes k is equal to 0. In the second case, we are getting minus 2k is equal to minus 16, or I can say k is equal to 8. So we are getting these two values for k. So let's learn this area of triangle. We extend this concept by writing equation of straight line joining these 2 points x1 y1 and x2 y2. So write xy is any general coordinate on the line. Then write first coordinate x1 y1, write the second point x2 y2, write down 1 in column 3, that is equal to 0. So this is giving you equation of straight line. Let us use this concept, this formula for finding equation of straight line by using determinant. So how will you start? Write general coordinate x, y, then write the first point 1, 2, then write the second point 3, 6. Make it square by writing 1 in column 3, equate it to 0. This half represents that this is area of triangle and it is going to be 0, but when half is multiplied by 0, it is losing its value. So you can simplify this determinant only. So let us simplify this. X multiplied by 2 minus 6 minus y multiplied by 1 minus 3 minus 1 multiplied by 6 minus 6 is equal to 0. Let us simplify this. Minus 4x plus 2y, this is giving you 0, so equal to 0. Multiply throughout by minus 2. What will you get? 2x minus y is equal to 0, which is equation of the line joining given 2 points. Let us summarize whatever we have learned so far. To every square matrix A, we can associate a number which may be real or complex, which is called determinant of the square matrix A. This is denoted by determinant A or this symbol or this symbol. Determinant exists only for square matrices. Determinant can be expanded along any row or any column. Determinant should be expanded by the row or column having maximum number of zeros so that your calculations become easy. You can expand by writing plus minus 1 alternately, whatever the case is. If A and B are square matrices of the same order such that A is equal to K times B, then you can use this property that determinant A is equal to determinant of K times B. You take K common, it becomes K raised to power N. Area of triangle with given 3 vertices can be taken as half times this determinant consisting of vertex 1, vertex 2, vertex 3 and last column 3 is consisting of only ones. Area of triangle becomes 0 if points are collinear. Equation of straight line joining 2 points x1 y1 and x2 y2 can be written as xy, x1 y1, x2 y2, write 1 in column 3, equate it to 0 and you will get the equation. So, this is all about determinants, how to evaluate it, how to apply it in finding equation of straight line, how to use it in finding area of triangle. So, in the next video session, we will learn more about determinants. Thank you everyone.